Hi, this is Francis Sideco with TIRIAS Research. I'm here with UltraSense's Dan Goehl. We met last year. I thought I'd come see him here at CES 2025 and get an update from him. Looks like a lot of really great, interesting things happening with their, really ultra high end, I would say. Even the stuff that's for the low end looks really high end to me. But I'll let Dan kind of walk us through the booth a little bit here and some of the things that they're showing. Go ahead, Dan.
Great. All right. So we're a chip company, and our chips are designed to replace mechanical buttons. We started in the smartphone market, but today the bulk of our business is in the automotive market. And we're showing off a variety of different products today where our chips can go into. So the first one I want to direct your attention to is the steering wheel market. A few years ago, there was a big publication saying how steering wheels with capacitive touch sensing weren't very good. Part of the reason why is because the force sensing wasn't implemented very well, as well as the haptic. So we've done that with our new steering wheel here, but we also have a new innovation of using our ultrasound technology to come up with a slider to get rid of the plastic scroller. So this is using our ultrasound, and this is really sensing through 3 millimeters of solid aluminum.
Nice. And I don't know if you can hear that, but I definitely feel the haptics as I'm sliding it up and down. So,
that's right.
Yeah.
So there is, the way the module is set up here, we have a piezo material. We stamp that, or we put 7 electrodes on there. This is all driven by our IC. And then we're able to accurately detect where the finger position is on the slider, and then we're able to drive the haptic motor, which is on the back side of this module.
And remind me again, I know I asked you this last year, but the ICs that you guys do you manufacture them yourselves, or do you use a foundry partner?
Yeah, so we're a fabless semiconductor company, so we outsource the building of the chips. So we use foundries in Singapore market. So our supply chain is mostly out of the China market. We do our packaging in Taiwan. More and more we get asked by tier suppliers and the OEMs themselves to design the complete HMI system design. And so we're able, through one of our investor partners, to be able to manufacture complete PCBAs, even plastics at their facilities. And they have fully automated factories in the Vietnam market. So we're starting to do that with one OEM that will be in serial production later this year. And then we have several partnerships that we recently announced, one with Antolin, another with BCS AIS technology out of China, and then Novum on some of the materials that you'll see here in the video.
Making the jump from tier 3 to tier 1.
That's right.
Exactly. That's a good thing to do.
But we gotta walk before we run. So we're happy with tier 3 and even tier 2 of producing modules.
There you go.
The other thing I want to show here is kind of the advancements for the future. We're showing our ShyTech technology with the electronics underneath. So we work with different material makers to really make these surfaces come alive, to become smart surfaces. And so that's what we have here. This is actually real cherry wood, and you can't make out any of the surface icons until light passes through.
Yeah.
Now, to effectively replace a mechanical button, it takes 2 touch technologies to do that. A lot of the first cars use capacitive technology, and with capacitive technology, if this was capacitive, each button would be triggering as I slide my finger over the surface. But we augment that with our force technology. We have a very unique piezoelectric force technology. And so with that, we're sensing a change, and we're really a strain sensor. So we're detecting the strain on the surface, and we can detect that strain down to about the 100 nanometer level. So you don't need to have a visual deflection of the surface for us to be able to pick up any sort of touch on the surface. There are other different types of force technologies using optical sensing, where they're looking at a change in the light intensity, or parallel plate capacitance, where 2 metal plates together, and as they move closer, the capacitance changes. With those, you do need to have a flexible surface. Those surfaces need to flex even 800 microns, but 800 microns of flexing plastic just feels very non-premium.
Yeah, and that's the thing that's impressed me between last year and this year is, and we'll probably see this as we go to the other parts of the booth, is the sheer variability of options of the different materials that you guys can do. It's amazing.
That's right. So if we kind of look over here on this side, we started the company to eliminate mechanical buttons in the smartphone. We got into a couple LG mobile phones, and unfortunately they ran production and then they exited the smartphone business completely. We do see the smartphone market coming back, especially with Apple's iPhone 16 camera control button. All the major smartphone makers are looking how to implement more buttons, but not cluttering the look of the mid-frame of the phone. So technologies like ours with touch on metal using ultrasound is the way to go. And so that's what we're showing here with this demonstrator, where our ultrasound is detecting touch through 2 millimeters of solid aluminum.
Yeah, let's take a look at the help.
So this is
Yeah, that's
analyzed
really
blacked
thin,
aluminum, and
yeah.
then this is, of course, the brushed aluminum.
Yeah.
But going forward in the future, we can go through, any sort of metal. The European automakers like to use metal. It's very premium. It's highly sustainable and recyclable. And then you can also, apply a different patina for each one as well. So you can have that unique look in the car. I should say we are in serial production today in 6 cars. 3 in China market, where we're in the steering wheel switch boxes, where our force sensing controls 8 buttons in the steering wheel. So this is both capacitive and force sensing. As we press on the surface here, you see absolutely no flexing of that surface. So good premium feeling. We're also in Hyundai Genesis vehicles in the infotainment button bars, which I'll show you here in a moment. But keeping that same theme of button bars in the car, we're showing a variety of different materials here. Some sustainable materials. This is actually recycled paper. This material can be found in some Mercedes today.
Yeah,
But it has our multi-mode touch sensing
it actually
technology.
almost has like a leather feel to it.
It does,
almost.
that kind of supple feel to the surface. And then for mid-tier, low-end cars, we can even paint polycarbonate.
Yeah.
So we work with one of our painting partners called Mankiewicz out of Germany. And if you look very closely, you can't even make out any icons in the surface. It's only until light passes through where that happens. So this is their latest chrome painting technology. And then, of course, they have the matte black technology.
And we talked about this earlier. Even though that's meant for lower end or lower tier vehicles, it still has that premium feel, which is amazing.
Yes, exactly. So that's what we aim to do here. And when you talk about premium, we have stone.
Yeah.
So this is actually a real stone veneer. The nice thing about it is that it does provide that uniqueness, but it does have a nice textured feeling to it as well. These are laser etched embossed icons, so you don't even need to look down. This is, yes, it's a flat surface, but these are slightly raised where you can actually make out where the button is located. I have another demonstrator over here where this is actually implemented.
So for these kinds of where you have multiple tiers of the materials, do you find that it's like the luxury brands that have maybe like an entry level where they want to maintain that look and feel that do this, or do you see some even just actual lower tier brands still also looking at this kind of material?
We see everybody,
Okay.
And all over the world, everywhere from India to Europe and all parts in between.
Okay.
So in India market, obviously those cars are lower in price, but they still want to have this type of functionality, and that's where a material like this, and I'll show you a PVC leather stamp material that is very affordable to go into cars like that as well.
Cool.
So if I direct your attention around the corner here, we're showing other Sideco materials like carbon fiber. And then here we can also do multicolor touch as well. We can do that with all of them. But for these demonstrators, this is the one that kind of worked out the best. And then when there's no light passing through, you can't make out any of the surface icons here. We saw this is real cherry wood. So just to show that again, here, this one is implemented with a slider that has haptic feedback. And then we go to that faux leather material, which is a PVC material, but we can also make that Shytech as well.
So the colors are great because I know on my vehicle I have both like a seat heater and a seat like blower, like for air conditioning.
Right.
And they have the LEDs that are red or blue for each one.
Correct.
But if you could do it all in one button, that's awesome.
Yeah, I mean, with lighting, there's a lot of different ways to implement our technology. We're showing our in-plane sensing here, where we put everything on a single PCBA, and then we have side-emitting LEDs with a light guide to force the light up to uniformly light the icon. If we want higher intensity, or if we want different colors, we would probably go with a different implementation, which is easier for us to do. But yeah, having multicolor is also a good indicator. And then it's also kind of safer driving because you know what's engaged and what's not engaged as well.
Well, and the intensity as well, because we all have those, with the dash intensity. Sometimes you want it a little bit darker.
That's right.
Or you want that uniform across everything.
Especially, so. And some of the automakers have pretty severe requirements for lighting, especially in sunlight.
Inside, yeah.
So if I direct your attention over here now. We're showing off even in kind of exterior application where at least what we're seeing in the China market and even the India market, mechanical door handles are going away. If you were to look inside what's in a door, the door assembly is actually pretty large. It's about 18 inches by 18 inches, almost 10 pounds. So by eliminating that, you can reduce a lot of weight in the vehicle. And then with what we have here, we created a nice, very tiny reference design to do the touch sensing in the B and C pillar. So with this technology here, it's using our multi-mode, again, both capacitive and force sensing. So as I slide my finger over the top here, you can see that it doesn't trigger. It's only when I cross that force threshold is where you get that haptic feedback and where you get it lighting up. Now that's absolutely essential for what I like to call the corner case of Norway in the wintertime, where it's super cold. You have a super hot power washer that's trying to get salt off the surface there.
So speaking of that, how does it work if you're wearing gloves, like ski gloves?
So by having that force sensing there, it still works. So the capacitive is to just give you the location where you know that there's a finger on top of the button. But it's only when you cross that force threshold is when it triggers. So you could still manipulate this even though you're using a big, thick, heavy glove to be able to trigger this just using.
I mean, a lot of the gloves now, because of smartphones, have capacitive tips, but it's always nice to not have to worry about that.
Absolutely. So we have a nice, very tiny reference design to be able to do that. Also, we get asked a lot to do, really cut down on weight across the vehicle. One of the things that we're seeing that's changing is the overhead console. Overhead consoles have traditionally been very large and very bulky, but now with EVs, the roof line is getting lower to reduce drag coefficient. And then also that's where all of the driver assisted cameras are going in that same area. So there's not a whole lot of space there. So with our one chip, we can control lighting. We can control, slider capability for maybe sunroof or sunshade. We have the haptic built into this as well. But the key thing that we're showing is that we can all do that in a form factor that's about 14 millimeters in thickness. So it keeps it, super lightweight.
Is that how thin as you can go, or can you go even thinner than
We
that?
could go even probably a few more millimeters thinner. We're looking at ways to possibly do that with some of our customers.
And I noticed this is kind of a plastic material. Are you able to use the same kind of materials that you showed in the other demonstrators?
Yeah, absolutely.
Okay.
But since this isn't in the direct line of sight, OEMs really don't want to invest the money of putting exotic materials. Maybe if it's a Rolls Royce or a Bentley, that could be done. But yeah, any material still could be worked with this.
Perfect.
Great. We have some other demos and some other design wins that we're showing on the other table over here. But we're quite busy in the booth today. But very much thank you for your time.
It's a good problem to have. It's
great.
Absolutely. Just, I guess, one last question is all of these great new innovations, if you're able to talk about it, when do you expect it to hit the road?
So some of these will be hitting the road middle of this year. Others would be model years 2026, model year 2027. So
Perfect.
we're right on the cusp of a lot of great things happening.
When we're off air, give me a list of the cars so I can look for my next car.
All right,
because I love this look and feel. Perfect.
Right.
Thanks, Dan. Always
Great.
good to talk to you.
Thanks, Francis.